In this lesson, we will examine the topic of cloud-native applications. Cloud-native applications are a way of building and deploying software that leverages cloud computing infrastructure and principles. They are designed to be scalable, resilient, and flexible, and are typically built using containers and microservices. First, let's define cloud-native applications and their components. Cloud-native applications are designed to run on cloud infrastructure. They are used to build highly scalable, resilient, and flexible applications that can be deployed on cloud infrastructure. They are designed to take advantage of the elasticity and scalability of the cloud, making it easier to scale applications as needed to meet the changes in demand. This makes it possible to run applications that are highly available even when faced with high traffic volumes or hardware failures. Additionally, cloud-native applications are designed to be agile and flexible, making it easier to deploy updates and changes quickly and effectively. Cloud-native applications are usually built using containers and microservices. Containers are a lightweight form of virtualization that allows applications to run in an isolated environment. These containers are lightweight, portable, and self-sufficient, making them well-suited for microservices. Containers allow developers to package an application and its dependencies into a single unit, making it easier to move the application between different environments. This allows for a more efficient and consistent deployment process and makes it easier to scale and manage the application in the cloud environment. Also, containers provide a consistent runtime environment, which helps it in avoiding the issues that arise due to differences in dependencies and configurations. This is because cloud service providers like Azure and AWS will manage the underlying infrastructure of the containers for your organization, making containers an excellent choice for developing cloud-native applications. Microservices, on the other hand, are a way of breaking down a monolithic or single large program or application into smaller, independent services that can be deployed and managed separately. Microservices allow each service to be deployed and scaled separately based on your organization's requirements. There are several advantages to using cloud-native applications, including scalability, resilience, flexibility, and cost savings. Cloud-native applications are designed to be scalable, which makes it easier to increase capacity as needed. This can help to ensure that applications remain responsive and available when faced with high traffic volumes. These applications are also built to be resilient with features such as automatic failover and self-healing. This can help to ensure that the application remains available even when faced with hardware failures and other types of outages. Another benefit of cloud-native applications is their flexibility, which allows them to be easier to change, provides your organizations with the ability to deploy updates much more quickly. This can help organizations respond to changing business requirements and stay ahead of their competitors. Cloud-native applications can also be deployed more efficiently and with less overhead by using containers and microservices. This can help to reduce costs, especially in large-scale deployments. Unfortunately, there are several disadvantages to using cloud-native applications, including their complexity, security issues, and the skill required to develop and deploy these native applications. Cloud-native applications can be complex, especially when compared to traditional applications. This can make it difficult for organizations to manage and maintain them effectively. These applications are also vulnerable to security threats such as data breaches and malware. This makes it important that organizations have robust security measures in place to protect their applications and data. Also, developing and deploying cloud-native applications requires a different set of skills than traditional application development. This can make it difficult for organizations to find the talent they need to build and deploy cloud-native applications effectively. So what does a cloud-native application actually look like? Well, chances are you've already been using some cloud-native applications and you didn't even know it. For example, the video streaming service Netflix actually uses cloud-native applications to deliver their content to millions and millions of users each and every day. Netflix chose to use microservices architecture to break down its entire application into smaller, independent services that can be deployed and managed separately. This enables Netflix to adjust its infrastructure to changing demand, keeping its applications responsive and accessible to all users. Moreover, Netflix uses containers to package and deploy its applications, which can help to reduce the overhead associated with deploying and managing its infrastructure. You may also be wondering how these cloud applications are actually managed on a daily basis. Well, your organization's cloud-native applications should be managed by your development and operations team, who work together to ensure that the applications are deployed and run effectively. This typically involves using DevOps practices, which are designed to improve collaboration between development and operational teams. DevOps is a culture, mindset, and set of practices that are designed to help organizations to deliver high-quality software faster and more efficiently. It is based on the principles of continuous integration, continuous delivery, and continuous deployment, and emphasizes collaboration, automation, and experimentation. In the context of cloud-native applications, DevOps can help to ensure that applications are deployed and managed in a way that is both efficient and effective. For example, by automating the deployment process, organizations can reduce the time and effort required to deploy updates and changes. Additionally, by using continuous integration and continuous delivery, organizations can ensure that the applications are updated and deployed quickly and efficiently without sacrificing quality or stability. Cloud-native applications require DevOps because they are designed to be scalable, resilient, and flexible, and to take advantage of the elasticity and scalability of the cloud. DevOps provides a framework for collaboration between the development and operations teams, as well as a set of practices that are designed to improve the speed, efficiency, and reliability of software delivery. By using DevOps, organizations can ensure that their cloud-native applications are deployed and managed in a way that meets their business requirements and takes advantage of the benefits of the cloud. Okay, so now it's time to do a quick recall. When it comes to cloud-native applications, these applications are a new way of building and deploying software that leverages cloud computing infrastructure and principles. They are designed to be scalable, resilient, and flexible, and are typically built using containers and microservices. By using cloud-native applications, organizations can take advantage of the elasticity and scalability of the cloud, as well as deploy and manage all their applications more efficiently and effectively. To do this effectively, however, organizations need to use DevOps practices. Now, these are designed to improve collaboration between the development and operations teams and ensures that the applications are deployed and managed in a way that meets the organization's specific business requirements.